Hello. Gonna look at some homework here and see if we can't help some people out. This is mostly gonna be for the 8th graders, 'cause I forgot to take home a copy of the 7th grade work, and also it was really easy, so I'm not gonna spend too much time there. I did want to look at this one that I vaguely remember seeing and thinking it might have given some people trouble. I don't know if this was the exact range of numbers, 1 through 31, but it was. Oh, interesting. All my colors are off. But it was a set of numbers and talking about probability of getting one that's prime. So in case you forgot what prime numbers were, all prime means is that this has exactly two factors. And those factors are always 1 and itself. Okay. It's important to note that it says exactly, which means the number 1 is actually not prime, because 1 only has one factor, and that's 1, right? So we look at all of our numbers that are prime between 1 and 31, and in case you don't have those memorized, you could always go online and Google first 1,000 prime numbers, and you get a list that comes up like this, and it gives you the first, 1,000 prime numbers, and the 1,000th is 7,919. Okay, whatever, but that gives us what we need up to 31, so we can list these out in blue here. So we have 2, this was blue, there we go, 2, 3, 5, 7, whoa, not 9, 11, I guess I should look at my list, 17, 19, 23, 25, and 27 are, 29 is, right, and then 31. Okay, so all these are prime, which means if we're looking for probability, these are our favorable outcomes. That's what we want of the numbers that are prime. So we count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 favorable outcomes. Out of how many possible? Well, it's all the numbers from 1 to 31, which means there are a grand total of 31 numbers. And there's your probability. So this is probability of prime. Okay. If the question said which of these are precisely a number that is not prime, then we could just take the opposite. So if 11 numbers are prime, that leaves 20 numbers that are not. So we can say that the probability that it's not prime is everything else. So that's 20 over 31. And if this number wasn't 31, then you make adjustments where necessary, but the basic concept is the same. As long as you don't try to say 1 is prime, because it's not. Okay. Also, an interesting thing about the list, if you look at them, I'll bring it back over here. Of all these 1,000, how many of our prime numbers are even? Just number 2. Okay. So if they ever try to give you like a trick question, like what's the sum of these two prime numbers? And they'll always give you the same kind of thing. They'll say like, what's the sum of two prime numbers that equals 81? Yeah, that's a good number, 81. All right. So if you think all your prime numbers except for 2 are odd, and you think that an odd number plus another odd number always comes out to the same thing, right? No matter what you pick, say this is 1 and 3, that's 4. So an odd number plus an odd number will always equal an even number. Okay, so if the sum has to be 81, it can't be two odd numbers together, right? Which means one of them has to be even, but since we're only looking at prime numbers, there's only one even prime number, and that's 2. So we're saying 2 plus something equals 81, and well, this is sort of obvious. This is just 79. So if they ever ask you to find the sum of two prime numbers, and that sum is odd, one of them is 2, and the other one is 2 less than whatever the sum is. So, fun fact for Monday. Okay. Alright, that's it for 7th graders. Y'all go home. Okay. 8th graders. Alright, so homework was kind of easy. So I tried to give you some that were fun, right? Fun questions and quotation marks. So a couple of them look like find lengths of the sides of a square whose area and perimeter are the same, and it's not 0, because if it was 0, then it would just be what's the point, right? You can't have a square with side length of 0. So how can we figure this out? Well, hopefully you've seen this example before, alright, and you just know what the answer is. If not, oh boy, we're in for an experience. So area and perimeter are the same, which means the area of a square, which that formula is s squared, has to equal the perimeter of a square, which is 4 times s, right? What value of s makes this the same? So we could move this over and then factor it, and that'd be a lot of fun, but I don't want to do that. So I'm just going to expand s squared, and I'm going to say this is s times s equals 4 times s, and then we look, they both have times s in common, so we can, in effect, just divide both sides by s and make that all cancel out, and we get s is 4. And we can check that. Does 4 squared equal 4 times 4? You betcha. So side lengths would have to be 4. Okay, that wasn't so bad. Alright, second one. This one, I can almost guarantee you've seen this one before, but that's okay. We'll do it anyway. Find length of the radius of the circle whose area and circumference are the same. So same basic concept. So pi r squared is formula for area. We want that to equal 2 pi r. Area, circumference. We could use pi d, but this is radius, so let's put radius over here because our goal is to cancel everything else out. All right, let's start easy. Let's get rid of pi. So we have pi on both sides. Pi, that cancels out. So we get r squared equals 2r, and then you should notice some parallels to our square problem here, but if not, that's okay. Expand this out, so r times r equals 2 times r, and if you haven't figured it out now, I'm feeling a little sad for you, but still okay. We can cancel out an r here by dividing both sides by r, and we get radius is 2. Okay, that's it. That was the first 2. Alright, number 4. I like this one. This one's always fun. And it's always the same answer, but they love to give you this question. So at some point, you'll figure it out, and then you'll know it forever. Snack breaks. Nom, 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 nom. Alright. That was probably gross, but whatever. Faye's got fencing to make a rectangular garden. So here is Faye's garden. It's a rectangle. She wants to enclose as much area as possible. So maximum area. Use trial and error to find the maximum area she can close with all 44 feet. Name that length and width. Okay, so we want to know trial and error. So let's make ourselves a table. Length, width. And we know that length and width has to work out such that 2 times the length plus the width equals 44. Right? That's our perimeter. This is our formula to find perimeter. So let's simplify this a little bit. Let's get rid of this times 2. So we divide both sides by 2. We stop using red because it makes me angry. And we get that length, length plus width has to equal 22. Okay? So we just pick sides that give L plus W is 22. So we could say 1 and 21 and 2 and 20 and 3 and 19, all the way down so we get to 11 and 11. And then we'd work backwards. This would get bigger and this would be smaller. And then I guess for the sake of explaining why that works, if this is 10, then this would have to be 12 and 9 and 13 and 13 and 9. But length and width are interchangeable, so we don't have to concern ourselves with this part, right? Because we're gonna get the same thing. So let's look. If this is our length and width, what's the area? So let's move this out of the way, and we can add a third column to our chart here. Area. And area is just length times width, so 1 times 21 is 21, 2 times 20 is 40, 3 times 19 is 57, right? 9 times 13, we skip ahead because we look as we go down the list, this keeps getting bigger, so we'll see if it gets bigger all the way through. So 9 times 13 is 117, 10 times 12 is 120, 11 times 11 is 121, right? Why did I just forget what 11 times 11 is? Why am I saying 121? I feel like going crazy. 0. Yeah, well, that was weird. Okay, 1. That's a 1. So, and then if we kept going the other way, this would actually start going back down until we got all the way down to 21 and 1, and that would just be 21. So we can see that it maxes out right here at this point. So this would be 11, this would be 11, and the area would be 121 feet squared. Okay? And then you should notice something, be like, well, this is not just a rectangle, it's actually a square, because the side, or length and width are the same, and you don't trust this picture. So then the question underneath it, which I didn't write down, or copy, says, how are perimeter and area related, or whatever, I don't know. The relationship is, if you're looking to maximize area in a quadrilateral, you want to get as close to a square as possible, which usually means make a square. So what number times itself? Alright? And that's it. That's your max area. No matter what grade level you're in, if you're trying to max out a rectangle, you actually want to make a square. Okay? So then it takes it a step further and says, what if she says, forget that, I want to make a circle? You say, okay. Sort of difficult to make a circle out of fence, but I guess if the Minecraft kids can do it with their cubes, then we can make a fence out of, make a circle out of fence, right? Okay, so find the area of the garden, use 22/7 for pi. So 44 feet is the fence, which means if this is a circle, perfect circle, that this 44 feet is the circumference, C, right? And circumference is 2 pi r. And then further it goes to tell us that pi is 22/7. And actually, I don't know why I keep writing c, because we know what c is. That c is just 44. Okay, times some number r. Okay, and this works out kind of nicely, almost if it's done on purpose. 2 times 22 is 44, divided by 7 times r. We just multiply these together. And then to get r by itself, we got to get rid of 44/7. So we multiply by its reciprocal, which is 7/44, because that cancels everything out except for the r. Then we do the same thing on the other side. And then we can simplify this. 44 on top, 44 on the bottom. That cancels out. 7/1 is just 7. So what is our radius? 7. Okie dokie. So the area of the garden, we go back to our formula for area. Area pi r squared. Okay, and this is just plugging in numbers now. So 22/7. And then let's do this. Instead of writing 7 squared as 49, duh, we know that, but let's just write it as 7 times 7. The reason for that is we still have a dividing by 7 here, so these will actually cancel out. So area is just 22 times 7, which is 154 feet squared. Okay. But now if we think about it and look at it, it's the same 44 feet. The same 44 feet we did to make this garden, which only had an area of 121 feet. So what that tells us is that if we want to maximize our area, we don't want to make any sort of quadrilateral, because that's always going to limit our options. So our ultimate inefficiency is to make a circle, a better circle than this. Okay, so if you ever want to have the most efficient use of perimeter in terms of area, you make a circle. All right, that's that. Not too bad. And that answers like question 7. And then I don't know what question this one was. It was pretty good. It wasn't even good, but it can be kind of confusing as to the way it says. Explain why area and perimeter can never be equal. They can only have equal numbers. You say what? Because if they have the same numbers, then they're equal, but not really. So let's take our perfectly drawn square here. There it is. If we say, what was the number we used here? We said a square had a side of 4. Let's say this is 4. This is 4. Then our perimeter equals 16, and our area also equals 16. And you say, why aren't these equal? It's a difference of units. So if this is 4, I don't know, miles, and this is 4 miles, the perimeter is just 16 miles, right? But the area is miles squared. And these are totally different things, right? Miles, that's just a unit of distance. That's just saying a straight line from here to 4 times that length, right? That's 16. But 16 squared, units squared, means that to make this box, we need 16 little tiny squares. Oops. You get the idea. And each of these are 1 square mile. You cannot measure area in distance. The same way you can't measure perimeter in square units, right? They're totally different. So these will never be equal because their units are different. And that's it. So let me put some variation of the words I just said. You will get the correct answer, and then you'll answer everything else, and those will also be correct, and then you'll get hundreds, assuming that you turn in your work, which everyone turns in their work. So that's it. Spiky hair and ear piercings. Okay. Good night.